David Simons is a senior engineer with the Texas Optimization Program and Response Team. He received his Bachelor of Science and Master of Science degree in Civil Engineering from the University of Texas at Austin. David worked for an environmental consulting firm in Dallas, held engineering positions with the cities of McKinney and Taylor, and worked for a civil engineering consulting firm in the Austin area prior to taking a position with the TCEQ in 2013. He provides technical assistance to public water systems and TCEQ regional offices and conducts on-site evaluations of surface water treatment plants and distribution systems. Please welcome David Simons.
Thank you, Nubia. Well, thank you everybody for coming. We're going to talk about free chlorine conversion strategies today. And I do want to let you know up here at the front by the young man, Don, there are a bunch of copies of our RG 631 that talk about temporary conversions to free chlorine. This presentation is based on that RG. So if you don't have a copy, please come up and get one. You can also download them off our website, as it talks about there. Just some overall messages here. You know, some Texas water systems use chloramines, and any system that uses chloramines can have nitrification. So chloramines are used usually to maintain residuals and meet disinfection byproduct regulations. If you do have nitrification going on, it can cause you to lose your residual, and that's really what we're here to talk about, how to fix that. And that can be stopped with a temporary conversion to free chlorine. You may hear that called a free chlorine burn. The second bullet here says, why not call it a burn? It's really better not to tell your customers you're burning their water. That's not what you're doing. I mean, you're just changing the residual type. You know, if you have to call it something, you know, if you don't want to call it a temporary conversion to free chlorine, I've heard stuff like, doing a refresh, you know, something like that. But for the most part, just for public relations, I would recommend, you know, don't call it that you're burning the water. As we said, any PWS that has chloramines could have nitrification, and so anybody with chloramines could need a free chlorine conversion. All right, so what is nitrification? I'm not going to go into a lot of detail, just an overview. There were other presentations like by Alicia Deal and Andy Waite that talked about it, but you know, the basics are you've got bacteria that they use ammonia as a energy source, and there's always going to be ammonia if you have monochloramine in your distribution system. These bacteria can then grow and multiply, and if enough are present, you can actually they can exert a demand on your monochloramine and cause your residual to go down. So when you have low disinfection residual, you can have, you know, this persistence and regrowth of bacteria. You know, the nitrification just goes on and on and on, and you can't get rid of it. The nitrifying bacteria, the ones that, you know, are processing the ammonia and nitrite, they are coliform bacteria. So you get enough of them in there, you know, you could get a total coliform positive results. The whole thing we're trying to avoid is potential illness for your customers, but you know, there could also be some ramifications such as violations for you. So how do you stop nitrification? The way you do it is you remove ammonia from the system, and that starves the bacteria that are using the ammonia as a food source. Out in distribution, you're always going to have some biofilm out there where these bacteria live, and you're not really trying to kill them with the free chlorine, you're just taking away the ammonia and starving them. So when you do this conversion to free chlorine, that removes all the ammonia from your distribution system. Let's talk about some pros and some cons, but a pro is it works. It's the only way to starve the bacteria that eat ammonia. You know, otherwise they can keep going and blooming and making the nitrification works. Just as a rule of thumb, I mean, starving bacteria takes some time. And you know, I would just recommend that at all points in your distribution system during a conversion, try to get at least 2 weeks of exposure to free chlorine. Don't just do it, and do it in 1 week and you only get a couple of days of free chlorine exposure at some points, because it takes longer than that to starve the bacteria. When you do the conversion, as already stated, there can't be any ammonia present because you have free chlorine. They don't exist together. So there are other things that can cause low residuals, and we're not going to really talk about them today, but there are other TCEQ presentations and training modules that help you figure out, what's causing my low residual, particularly if it's not nitrification. So one of the cons is you, as the manager and operators, you do have to do a lot more work than normal during a free chlorine conversion. You've got to do some work ahead of time to figure out, are our chlorine injectors even big enough to breakpoint chlorinate? That could be an issue. How much chlorine are we going to have to add? Because your chlorine could likely, it's possible you're going to have to increase your chlorine during the free chlorine conversion, so you're going to be using more. All your valves out in the distribution system need to be operable. And when you're flushing, as we'll talk about in more detail, that's just more time your operators have to spend. So just keep in mind, this is going to be a pretty time-intensive exercise. And then you've got the monitoring that you do at the start and the end of the conversion. Again, just added on to what the operators have to do. Some other cons you could have. Odor calls. If the free chlorine isn't flushed through the system quickly, there may be areas that have this unstable chlorobene, dichloramine, and trichloramine that smell bad, and you want to try to avoid that. So getting the free chlorine through quickly is probably the best way to avoid that. So this is kind of a graphical representation of what I'm talking about. When you've got the free chlorine coming into the system from the left, and you have monochloramine leaving the system, you're always going to have some amount of dichloramine and trichloramine between the pure free chlorine and the pure monochloramine. What you're trying to do is just minimize how much of that is going on, because there's always, in that conversion through the breakpoint curve, you're always going to have a little bit of that. Some other potential odor calls, the customers will probably notice a difference in taste or odor, just the change from chloramines to free chlorine. And it's a good idea before you do the chlorine conversion just to notify your customers, hey, this is what we're doing. You may notice a change in taste, that we're not adding so much chlorine that it's going to, burn your skin or anything. You may smell it, but what I'm saying, just try to set their expectations ahead of time. Color can be an issue. If you're one of those systems that maybe has iron or manganese in it, you may have those sediments in your distribution system, and the extra flushing you're doing during the free chlorine conversion can stir those up and oxidize metals, and you can get color complaints during the free chlorine conversion. I say here, you might want to consider, if you are one of those systems that has a lot of iron and manganese, and that flushing is gonna cause problems with color, maybe do some of the flushing ahead of time before the conversion to try to clean them out before you start the conversion. And again, it's a good idea to set the expectations for your customers. One of the important things at some of these conversions are your booster chlorination units sized to breakpoint the chloraminated water they treat. In general, I'm talking about your purchase system, or you've got a booster plant. You've already got chloraminated water coming in. You've got to add enough chlorine to breakpoint chlorinate those chloramines. It's not as simple as you're going to, our wholesaler is going to switch to free chlorine for us. They may, but if they're not, you have to consider, if you don't have any booster chlorination, then no, this isn't going to be a problem. But if you are going to try to break point with your booster disinfection station, have you ever tried to do that before to see if you can actually accomplish it? Again, your chlorine injectors, if they're just sized for booster disinfection, they may not be big enough to actually break point chlorinate the water. And there's some help in the appendix of the guidance manual that kind of takes you step by step through how to figure out how much of a chlorine injection capacity will you need for your particular water. All right, so let's talk about planning the conversion. We're going to talk about flush sequences, tank levels, et cetera. And it's, in most cases, it's more than just turning off the ammonia feed and going about your daily business. We'll go through a few overview slides here first, but any of the words you see highlighted in blue here, we'll come back and talk about in more detail after I get through these overviews. So you need a source of free chlorine water. It can either be your plant, or you can get the upstream system, if it's yours, or wholesalers to provide free chlorine for this. And, as we've already noted, the planning is going to be different if you are the system that injects chlorine and ammonia to create monochloramine versus the purchase water systems that purchase chloraminated water for redistribution, particularly if they have no treatment of their own. They're going to have to work something out with the wholesaler. So you need to have a schedule. You're going to plan to flush the free chlorine through the system quickly and efficiently. You're going to have a sequence of flushing, and we'll talk about that in more detail. A sequence all the way from your entry points to the far reaches of the distribution system. Usually you want to drop your elevated tank levels and your ground storage tank levels just to make the conversion process go quicker. And you're going to be doing monitoring during the conversion to make sure everything's going the way you expect. You need to have a communication plan, and we'll come back and talk about that in more detail. Let's go back to the source of free chlorine. If you're a system that has raw water treatment and you're adding the free chlorine and free ammonia, that is the easiest situation, and just turning off the ammonia may be the way to make that work. If you're boosting pretreated water with free chlorine and free ammonia feed, you need to turn off the ammonia and turn up the free chlorine to go through breakpoint to make a free chlorine residual. And as I mentioned before, if you're a system that purchases water and you don't have any kind of chlorine feed or booster disinfection, the only way you can make this work is if you coordinate with your supplier. So the amount of free chlorine. The dose of chlorine must be high enough to overcome any ammonia, monochloramine, and free chlorine demand in the treated water that you're trying to then breakpoint chlorinate. You're going to have to do some calculations. Again, in the appendix of the guidance manual, there's help on how to do those calculations. It's not uncommon to find that your chlorine injection system isn't big enough to handle converting the water to free chlorine, but go through the manual, and if you're having trouble figuring out, hey, is this working or not, you feel free to reach out to us. We can help you with that. All right, let's talk about the flush sequence. We talked about you need to flush from the entry points, but you don't want to just go immediately to the end of your distribution system and open up, fire hydrant flush points. That's not the way to do it. Wherever your entry point is coming in, you want to have flush points near that entry point, and then successively work out to the end of the distribution system. And then, this is one where you want to make sure and talk about this with the operators beforehand, not just try to figure it out in the field as the conversion is going on. Again, to make the flush sequence work, all your flush valves and other valves that are out in the system need to be operable. So you're going to have to go through and find any valves that aren't working and get them fixed before the conversion. All right, so just to highlight what we're talking about, in this diagram, let's just assume this is kind of like a really simplified distribution system where the treated water is coming in, and then each of these branches is, some part of the distribution system with houses and everything else. So basically, water's coming in this way. What you don't want to do is immediately go to the end of the distribution system and start flushing. What can happen is in those areas, that are in the midsection of your distribution system, they're sucking in a little bit of free chlorine, and it's not really a good idea to have a little bit of free chlorine mixing with monochloramine, because you do get those, they have that potential for di and trichloramines when you're doing that in both locations. So don't do this. What you do want to do is first flush at the areas closest to where the water's coming in, then move to the next farther areas in the system, and then finally, once at the end, you can flush. So as I mentioned before, tank levels. You want to decrease the amount of water in the tanks, normally during a free chlorine conversion, just so it's easier for that free chlorine to take over the tank and in the distribution system. So the way I want you to kind of picture this is, if you have full tanks and they're full of monochloramine, it's obviously going to take a lot more free chlorine to overcome and breakpoint chlorinate that monochloramine. It'll make your conversion slower, and it costs more because you're just going to have to add a whole bunch more chlorine. So consider these as tanks, and it's showing some chemical coming into the tank and how it mixes over time. So this is beginning, middle, and later time, and you can see that there's big volume in the tank that stays, if we want to say in this case, monochloramine. But a smaller volume is actually easier to convert. If you only had the tank half full, it would convert over to free chlorine a lot faster. That's what we're trying to illustrate there. So, talk about monitoring. How can you tell where the free chlorine is? The only way you can do that is by monitoring. So during the conversion, at each flush point, you want to measure total chlorine, free chlorine, monochloramine, and free ammonia until you know you have completely turned that over to free chlorine. And you know you have free chlorine when the total chlorine is approximately equal to the free chlorine, and you've got no free ammonia. I say allow for approximate values. Ammonia, on your testers, if you get 0.05 or less, that's close enough to zero. You can consider it zero. But if you got 0.3 milligrams per liter of free ammonia, you still got some ammonia there. So the communication plan, you're going to have an internal communication plan, just so that you as operators and your managers are on the same page. For all the people that might be helping, you might have some people that aren't operators helping with the conversion. It'll just a good way to let them know what's going on and what's expected. External communication plan. You need to let us know before you do a free chlorine conversion. And I put up here that you need to contact our disinfection byproduct team. Sending an email to them here is probably the best way, but you can call if you want to let them know, hey, we're getting ready to do a free chlorine conversion. The really important reason for y'all, the benefit for y'all for letting us know, is if you have your regular DBP samples, your TTHM and HAA5 samples scheduled, and they're going to happen in the middle of your conversion, your DBPs are going to be out the roof, and you want to try to avoid that. Please let us know, and then please also talk with your chemical suppliers and your wholesale customers if you have them, so they can take advantage of the free chlorine conversion if you are a wholesaler. As I mentioned before, I think it's a really good idea to let your retail customers know what's going on. You're trying to do good things to make them to give them safe water, and then set their expectations for all the odor, taste, color issues that might come up. How long will it take to flush free chlorine through your entire distribution system, including tanks? It's going to vary by each system, so you're going to have to kind of figure that out. The key is add that amount of time at the beginning of the conversion, and remember, at the end, you're going to flush monochloramine back in, so you need to add the times both at the beginning and the end of the conversion, and then estimate how long do you need the entire conversion to last. So if you're going to follow my advice and try to expose every place in distribution to 2 weeks of free chlorine, and it's going to take you 3 days to get it all flushed in the beginning and 3 days at the end, then you're looking, minimum, like 3 weeks to run this conversion. All right, so let's give you an example. This is made up PWS, and just want to point out, so let's say their source and their treatment is down here in the lower left. The thicker lines represent larger pipes, and of course, smaller lines and thinner lines. So before the conversion, you're going to check your flushing strategy, start near the plant, work out to the far reaches, make sure everything's working. Does everybody understand what they need to do? Plan about how you're going to, how low to drop your tank levels. I mean, more you can drop them, the easier it is. If you could, if you're a city and you have concerns about, fire flow, it's possible that you might stage dropping the tanks. I mean, it might not be too easy if you only have one pressure plane, but if they're in different pressure planes, you might leave one full while you're turning over another one. And then you need to calculate what is your free chlorine dose that you need to add to get to the free chlorine residual you want. through the breakpoint curve. So identify your flush valves. So in this case, we've got here's the source and treatment, and then we've numbered some points that have been identified to flush. Now the numbering here does not match the sequence that you would want to actually flush. Again, you want to start near the source, so maybe flushing at number 1 and number 9 first would be the right first thing to do. Then maybe you could flush here at 6, 7, and 8 next to kind of convert this part of the system. And it looks like maybe there's some railroad tracks going across here. You might flush 3 and 4 next. And then finally, the very ends of your system, 2 and 5. So just keep that in mind about how to sequence your flushing. Starting the conversion, you're going to lower the tank levels, turn off the ammonia feed. You may have to increase your free chlorine injection rate to overcome anything that's coming in the incoming water, and then flush free chlorine through the system, in sequence as we already discussed. So way to illustrate that is, let's say at the beginning the free chlorine is pink and the monochloramine is green. So you're in this part of the animation here, you're just starting to get free chlorine into the system, just flushing the first parts. Then you're going to flush a little bit, get more of the system converted, and then finally get the whole system converted. So again, it's just trying to emphasize that sequential process of flushing. So during the conversion, you're going to monitor total chlorine, monochloramine, free ammonia, and free chlorine at each of your flush points until free chlorine is equal to total chlorine, and your free ammonia and monochloramine are essentially 0. At that point, during the conversion, you've got free chlorine at your flush point. For the rest of the conversion, until you flush monochloramine back, it's fine to just measure free chlorine. You don't have to run all 4 of those tests for the whole 3 weeks or month or whatever your conversion is. It's just during the flush periods at the beginning and end that you need to run all 4 to be sure where you are with your residual. At the end, switching back to monochloramine, it's the exact same sequence you did to flush the free chlorine in. So you've got your whole system is full of pink free chlorine, and you start flushing, turning on your ammonia and sending monochloramine back through the system in just, same sequential process. So when you end the conversion, you went through the same sequence of events, including lowering tanks. You're going to repeat all monitoring to make sure that you've got monochloramine there. At that point, free chlorine should be 0, and your total chlorine and monochloramine should be about the same, and you should have some measurable free ammonia. And then it's important, once you've done this, to write down your lessons learned for next time. Do the same things, and then go back. Once you're done with the conversion, you can go back to your normal type of monitoring. And it's always a good idea to let us know when you're done, too. So what if the free chlorine conversion is not enough to fix the problems? You have these recurring issues with nitrification, and the free chlorine conversion doesn't fix it. You may need some longer-term solutions, and those are really outside of the scope of this talk. So I recommend you get some professional help with that. Some of those examples might be, you've just got areas that are hard to get residuals to. You might need to loop mains and eliminate stagnant areas, possibly add tank mixers or modify the inlets and outlets on your tanks to make them more efficient. Maybe adding some booster disinfection out in distribution is a good way to try to deal with it. And there could be a lot of other things you might think about for those other types of actions when free chlorine conversion isn't enough. So other tips, again, just repeating, starving bacteria takes time. Plan to expose all the parts in your distribution to free chlorine for more than just a few days. Like I said, rule of thumb, 2 weeks is a real good number to shoot for. Just keep in mind that we as TCEQ, we're reluctant to let you do free chlorine conversions for longer than 30 days. If you've only got a max 30 days to do the conversion, you may need to do your flushing really efficiently to minimize how long it takes to get everything turned over and turned back. So you get the most amount of time with everything exposed to free chlorine. Now, the reason we're reluctant to let you go more than 30 days is this concept of normal operating conditions. I talked before about you inform TCEQ before you do the conversion so you can to our DBP team, so if necessary, they can reschedule your DBPs. Now, we can look at a 30-day period as abnormal operating conditions, and reschedule the DBP samples around that. If you go longer than 30 days, then we start to look at it as, well, it's more like normal operating conditions, and all bets are off. So, if you want to do a 60-day conversion, not that anybody would, but if you were considering it, it'd be much more likely that you wouldn't have any choice but to have DBP's samples collected in the middle of it. And you can get help with this. You can get some free on-site assistance through our financial, managerial, and technical assistance providers. They can help with tank cycling, valve sequencing, and a plan for working with your customers. Nitrification is always going to be a risk for any system that has chloramines in it. You can stop nitrification with a temporary conversion to free chlorine, but as I hope we all learned here, a lot of planning is necessary to make that free chlorine conversion successful. All right, so that's the presentation. Do we have any questions?
For those of us that are purchased water systems, and our treatment plant does the conversion for us before it gets to us, do we still need to notify TCEQ that we're going to go through a conversion?
Typically, when your wholesaler notifies TCEQ, they will ask the question, who are your wholesale customers, your purchasing customers that are also going to be taking part in this. If your wholesaler doesn't give that information, it still might be a benefit for you to at least ask our DBP team, hey, do you know we're going to do the free chlorine conversion at the same time that so-and-so is doing theirs? It wouldn't hurt anything to do that.
Okay.
Yep.
Thank you.
Thanks.
On the 2 weeks for the conversion, is there a time frame for us to ask for permission? A month in advance before we do the conversion?
If you have your DBP samples coming up really soon, it's better to do it early rather than late. But if your DBPs aren't going to be collected until after the conversion, a week notice, that's fine. Even a few days would be fine. It's really when you have that concern of DBP samples being collected in the middle, you don't want to let that happen because, good question. Thank you.
If I have a small pocket of my system that is having trouble, am I able to do a conversion just in that small area of the system, or would you recommend doing a system-wide conversion?
So you're saying for that small area, it's got its own booster disinfection. How would you, in this case, accomplish just a small part of your system converting to free chlorine? You must have some kind of chlorine injection out in distribution.
I was giving a hypothetical, but
okay.
So in the scenario I'm particularly thinking of, I do not have a booster capability at any of the pump stations, but if I could do, something more similar to how you would disinfect a line, like superchlorinating, but type of thing. I know it's not ideal, but you would recommend doing a system-wide elsewhere for that scenario?
To do a temporary, do a conversion just in part of your system, you would still need to get TCEQ plan approval. We'd have to approve all your injectors. You're talking about a lot of work and hassle. It's probably easier to just do the whole system if you're not set up to do a small part. But if you do have that, that was your original question. I've got part of my system, it's got its own booster disinfection. I know I can breakpoint chlorinate at the booster disinfection. That would be fine for you to just do that small part.
Okay, so chlorine conversion, should we only do that after indication of nitrification, or is there any benefit to do chlorine conversion prior to that?
Yeah, no, that's a great question. So a lot of PWSs say we're going to do it once a year, whether we need it or not, and we like the results. It would also be fine if you only do it once you have indications of nitrification starting. So it's really your choice. Obviously when nitrification is happening, you need to do something, and this could be one of your actions. But just general distribution system maintenance, you may want to do it on a planned schedule. But a lot of them will do it in the spring before the hot weather in the summer when nitrification is more likely to happen. So, yeah, good question. Thank you.
When we do a free chlorinate, do we expect issues with THMs? Or
Yes.
THMs rising up?
Yeah, if particularly if, I mean, most systems that use chloramines or a lot of them are surface, they're either purchased surface water or, surface water treatment. All those TTHM precursors, TOC, et cetera, bromide, they're still going to be in the water. So yes, during a conversion, you should expect your DBPs in most cases, particularly if this is originally a surface water source, the DBPs are going to go out the roof. And so that's why we try to work with you to avoid, you've got, most of the time you've got, 40 micrograms per liter of TTHM, you're running great. And then you get, 300 micrograms per liter of TTHM during the conversion, and that takes so long to work through your locational running annual average that you don't want to do that if you can avoid it. It's just a big hassle for you. So yes, you should expect the DBPs to go up.